Hello everyone. So let's solve today's LeetCode POTD. Best time to buy and sell stock using strategy. So the problem states that we are given two integer arrays, prices and strategy, where prices of I will be the price of a given stock on the ith day, and strategy represents a trading action on that day. So if the value is -1, that indicates we can buy 1 unit of stock. Means, and if it is 0, it means we will be doing nothing. And if it is 1, then we'll be selling that particular unit of stock. Okay, now we are also given an integer k, and we can perform at most one modification to this strategy array. And a modification will consist of, like, we can say select exactly k consecutive elements in the strategy and make the first k by 2 elements to 0 and last k by 2 elements to 1. And this k will be obviously even, so that this k by 2 has same number of elements. Now the entire profit is defined as sum of strategy of I into prices of I. Because strategy of I is 1, that means we will be able to sell some stock. Okay, so we'll be getting a profit here. And -1 indicates we are buying it, so we'll be paying, so that's why it is represented by -1. So there is there is also a note that there are no constraints on budget or stock ownership. Okay, so all buy and sell operations are means feasible. Okay, yeah, there's no constraint on we should have a stock, then only we can buy it or sold it. Okay, the sum profit is simply sum of strategy of I into prices of I across all days. So we need to return the maximum profit that we can achieve after performing at most one modification. Means we can choose some say, k consecutive elements of segment and set first k by 2 to 0 and last k by 2 to 1. And means both the lengths can go up to 1e5 and k is less than or equals to 1e5 as well. Okay, and a strategy will only have these values -1, 0 and 1. So let's see the given input. So we have 4 to 8. Okay, so suppose, and the strategy is this. Strategy was -1, 0, 1. So let's if we do not apply any modification, then what will be the profit? So it will be -1 into 4 plus 0 into 2 plus 1 into 8, which is equals to 4. Okay, let's apply some modification starting from this index. Okay, so 2 length. So the first element will become 0, second element will become 1. Now the profit will be 0 into 4 plus 1 into 2 plus 1 into 8 equals to 10. Okay, now let's try to modify this part. Okay, so it will be the same, it will remain the same only, -1, and then 0, 1 will be the first k by 2 elements will become 0 and the last one will become 1. So it will be same only. Okay, hence the profit will also be 4 here. As you see, the maximum profit that we can get here is 10, and which is the output here. Okay, so hence there may be also the case that we are not applying any modification and still able to get the maximum profit. Okay, for example, in this input we have means strategy as 110. So we saw when we did not apply any modification, that we were able to get the profit as 9, which was the maximum possible. Okay, since we need to apply at most one modification. So what can be the most brute force way of solving it? So brute force way of solving it would be to simply for each k length segment, we apply the modification and then find out for each I from 0 to n minus 1 the profit prices of I into the strategy of I. Okay, so let's analyze the problem statement. So we are given a sequence of stock prices and a fixed strategy. We want to maximize the total profit. So total profit will simply summation I equals to 0 to n minus 1 strategy of I into prices of I. Now we are allowed to change one segment of length k. First half becomes 0, second half becomes 1. Now we need to find such index I that maximizes the profit after this change, or choose not to change anything, because if the profit is already a very max. Okay, so brute force approach would be to simply first we calculate the original profit so that we are able to find this if we not applying any modification. So in this case it will be simply what sum of strategy of x into prices of x for the entire array. Now we need to iterate through all possible starting indices of each segment of the segments. Okay, so this start index can go from 0 till n minus k, because n minus k, the window will be from n minus k till n minus 1 of k length. Okay, so we will iterate through all the possible of these windows, and then we'll identify the window range. So for a particular I, the window range will be from I till I plus k minus 1. So now if we have this original part and we have this part as window, so we'll find the old profit, we'll find the new profit, and if this new profit that we have is greater than old profit, then we'll simply add this part and the old new minus old, and then we'll be getting the current profit after modification in this current window. Okay, then we'll be changing the window for, means this I will change, so the window will become like this, and we'll be doing it in a brute force manner. So like we'll calculate the old window profit. So old window profit contributed with this segment will be simply what, from j equals to I till j equals to I plus k minus 1, it will be simply this. And now after modification, the values from I till I plus k by 2 minus 1 will become 0, and from I plus k by 2 till I plus k minus 1, it will become 1. So this part will contribute 0 only. So only need to sum this part. And this part, we know like all the strategies will be 1 only. So we simply need to sum the 1 into prices of j will be simply prices of j only. So hence for each value from I plus k by 2 till I plus k minus 1, we simply need to sum the prices of j. Okay, so it will be what? P new will be 0 plus for j equals to I plus k by 2 till I plus k minus 1, it will be prices of j. Now the net gain will be simply P new of I minus P old of I. And if like this value is greater than 0, then means the answer will be for this current window will be P original plus max of 0, or means if it is negative then we will take 0, else this. Okay, so this is like the maximum profit that we'll be able to get in each window, and then we'll apply it for shifting the window by shifting this I. Okay, so as we know, like each calculation that we are doing inside means calculation of P old as well as calculation of P new, it is of the order of big of k, and there can be big of means there can be n starting points for these i's, right? So the overall complexity here would be big of n into k, and we know like both can go up to 1e5, so this will be like big of 1e10, which will give us TLE here obviously. But let's see the approach first, so that like the approach becomes clearer, and then only we'll try to optimize this approach. Okay, so brute force approach would look like something this. We find out the original profit that we had. Okay, so original profit will be simply the product of strategy and prices for each element from 0 till n minus 1. Now we'll need to find the POG plus max diff. Okay, max diff here means P new minus P old. Okay, so if we simply find this maximum diff, then we'll be adding this with this maximum profit. So we'll be adding it to the original profit, this maximum difference that we can get, and then we'll be able to get the maximum result. Okay, so the old window sum will be simply from I till I plus k minus 1, and the new window sum will be from like means from I till I plus k by 2 minus 1, it will be 0. So we'll be starting from I plus k by 2. So I plus k by 2 and j till I plus k minus 1 will be adding our new window sum. And now the maximum, the current difference that we'll have is this. So the maximum difference that we can create here is, if it is greater than the current maximum difference that we have, we'll be updating this max difference, and then we'll simply return the original profit plus the maximum difference that we were able to create. Okay, so this is what will follow, and this will be like the order of n into k complexity approach, and hence we need to modify it further or optimize it further. So where can we apply the optimization? So we know like we'll definitely need to go through all the starting points of the windows, right? Because we'll be definitely need to move this. Now this part that we are doing inside of finding out the sums, we are doing it in big of k. Okay, but we want to do it in constant time, then only we'll getting accepted. So we know like what do we need to do? We need to find the range sums. Okay, we need to find the range sums in constant time. So in constant time we want to find the range sum. So obviously maybe we can try to think of prefix sums here. Okay, and if you like to calculate the prefix sum of these values as well as the prefix sum of these values, then maybe these two values can be calculated in constant time, and then the entire code remains the same. We just replace, means do some recombinations and calculate these two values in constant time. So let's see the approach for the optimal one. So the optimal approach will be simply the prefix sums or sliding window. Okay, so we can calculate the old window profit and the new window profit for every I in big of one time using prefix sums. So what prefix sums we'll need to create? We'll need to create like one prefix sum of actual contribution, because in old window we need to sum these values, strategy of j into prices of j. So one prefix sum will be creating to store these values. So it will be simply what? It will be a of x equals to a strategy of x into prices of x. So the prefix sum will be sum, means a sum of 0 till j. Okay, for ax, for this value. Okay, and the second one that sum we needed was for p new. We wanted the sum for prices of j. So we can create a prefix sum for prices of j alone. Okay, so it will be simply j equals to 0 till j of the prices of j. Okay, now the old window sum will be simply what? It will be simply what? It will be from I plus k. We had I plus k, and we needed to remove this ith part, right? So if the current window is from I till I means if the current window is from I plus 1 till I plus k, so the old window will be means the sum of old will be prefix of I plus k minus this prefix of I. Okay, so old window sum will be this, and the new window sum will be from I plus k by 2 till I plus k minus 1, right? So it will be simply I plus, if we remove, like if we have made this as one based indexing, so here it is one based indexing, so for I to I plus k minus 1, it will be simply this only. Okay, so this is the same, and here also since we have taken it at one base indexing, so it will be like I plus k minus prefix of I plus k by 2. We can also take it zero based indexing, then it will be corresponding to these indices only. But in that case, we will need to handle the zero case, means I equals to 0 case separately, means the indexes should not become negative. Okay, so that's why we have keep it one base indexing, and now it becomes clear. So the profit will be simply original plus S of new minus S of old of I, and hence we'll need to maintain the maximum profit, so which will be the maximum of these values for each window. Okay, so I hope like the logic is clear. Once we write the brute force code, it becomes simple. Like the only thing that we needed to optimize was the sum part that we are doing, and to optimize the sum part, we saw like we just simply need to find the sum of these values in range and sum of these values in range. So maybe we can create two prefix sums to maintain these sums, and then we'll be able to calculate these values in constant time. So that is what we tried to do, and we are able to do that. Now let's try to see the code. So it will be like, it will remain the same, it will look the same as brute force, only this two parts will change and the prefix calculation part will change. Okay, Maki, everything else remains the same only. So we have the same prices size. We create this original profit which we have created in brute force as well. Now this part is new. We want to do the pre-computations for original as well as prices. So original will be prices of I into strategy of I. So we'll be calculating that, and prefix of prices of I will be simply prefix sum for prices of I. Now this again, this part is the same only. This part remains same. Old window contribution we are doing in constant time. Then this also we are doing in constant time. Baki everything else remains the same. Okay, so old window contribution was I plus k minus prefix origin of I, and it was I plus k minus prefix prices of second half start, which was I plus k by 2. Since these are one base, that's why we have taken I plus k, not I plus k minus 1. Okay, and then we'll calculate the maximum difference, and then simply return the original profit plus maximum difference. So as you can see, like we optimized the approach that we had initially of finding out the sums in big of k to constant time. Okay, so hence the overall complexity now boils down to big of n, which is of the order of big of 1e5, which will get accepted here obviously. So let's try to submit the code as well here, and see how much time it takes to run. This is the same code that we discussed. We have used one bit prefixing, so that this like the values does not become like means we do not need to handle zero separately. Okay, so it runs in 13 ms, which is real fast for these kind of pre-computations. And yeah, if you like I hope like you were able to solve it on your own. Means once we try to write the brute force code on our own, then we'll try to like see what optimizations we need to make, and from that we derive that prefix sums can be means a utility here, and then we are able to solve the problem. So I hope you were able to follow along with both the approaches, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.